Hello, hello, and welcome here to section 4 of chapter 9. We're now talking about the quadratic formula, and this is the last and final way that we have to solve a quadratic trinomial. Okay, in chapter 8 we solved it by factoring, and so far in chapter 9 we've solved it by graphing, by completing the square, and now the last way is quadratic formula. All right, so let's take a look here. The formula itself is one of the longer formulas you've seen in your mathematics career thus far. It's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay? Some of you are still probably looking at that and thinking, what are all these a, b's, and c's? Remember, a quadratic formula or a quadratic equation is ax squared plus bx plus c. That's where the a, b's, and c's come from. So if you haven't learned that by now, you better get on that. That a comes in front of x squared, b comes in front of x, and c is added on or subtracted on at the end. Okay? So the nice thing about this is that it works for every single quadratic trinomial that you see or quadratic equation that you see. It will work every single time. Okay? So, but it's a longer process most of the time. It has a long formula with it. And so those are kind of the drawbacks to using it. So let's go ahead and get into example 1. First thing I always like to do is identify what my a, b, and c are. Okay? My a is 1. My b is -2. My c is -24. Okay? A came from here, b here, c here. So then all we have to do is go ahead and plug this into the formula. I have the opposite of b, the negative of -2 is +2, plus or minus the square root of b squared, so -2 squared, minus 4 times a times c, all over 2a. Okay? So now we just get down to simplifying this. 2 plus or minus square root. I know that -2 squared is 4, minus 4 times 1 is 4. 4 times 24. Oh, I'm sorry, that's supposed to be -24. 4 times -24 is 96. So minus -96. And I know minus a negative becomes plus a positive, all over 2. Okay? So if we keep going, we'll have 2 plus or minus the square root of 100 over 2. The square root of 100, we should know, is 10. So I have 2 plus 10 over 2, or 2 minus 10 over 2. That's what that plus or minus means. Remember, a quadratic formula or quadratic equation always has 2 answers. So right there is where we're getting our 2 answers. Is 2 plus 10 or 2 minus 10. This gives me 12 over 2. This is -8 over 2. And so one answer I get x equals 6. The other I get x equals -4. All right? That's the quadratic formula. Whew. Hope we caught that. Like I said, it'll work every single time for a quadratic equation, but it's not always the quickest. Okay? This one, if you put a little bit of thought into it, you would have been able to factor very, very quickly and got x equals 6 and -4. Okay? So it's not always the best method to use, but it is a method that will work every single time. Let's take a look at example 2. 24x squared minus 14x equals 6. Remember, first thing we have to do is always make sure it equals 0. So 24x squared minus 14x minus 6 equals 0. Then I can pull out my a, b, and c. A is the first number, 24. B is the second number, -14. And c is the third number, -6. Okay? So from here, let's go ahead and fill it in. Opposite of b makes the -14 become positive, plus or minus the square root of -14 squared minus 4 times a times c all over 2a. Okay? A lot of big numbers. You have to make sure you're doing this math correctly. Okay? Memorizing the formula is not the hard part. Figuring out how to plug it in is not the hard part. The hard part for this formula is doing the math here, because there's so many negative signs and so many places where you can mess up the arithmetic that if you do, it's going to mess everything up. Okay? So if I fill this out or start to simplify it, I get 14 plus or minus negative 14 squared is 196. And if I multiply out 4 times 24 times negative 6, I'm going to get negative 576, and minus negative becomes plus a positive, all over 48. When I add those together, I get 14 plus or minus the square root of 772, all over 48. Okay? Now, we don't know the square root of 772. Even if you get your calculator out, it comes out to be some sort of decimal. All right, I'm actually double checking that right now just to make sure I didn't make a mistake on my notes. So 772, take the square root. Yes, that's correct. It comes out to be 27.7. Anytime that thing inside the radical comes out to be something other than a perfect square, we can just leave it right here. Okay? So in our first example, we got a perfect square. We knew the square root of 100 was 10. We could simplify it all the way down to a number. I don't know the square root of 772, so it's much better and much more beneficial for us just to leave it as this, because it's an exact answer. If we were to take the square root, we get 27.7. That's rounded, and so it automatically makes our answer incorrect because it's rounded. So just leave it as 14 plus or minus square root of 772 over 48. Okay? Later in high school, you're going to learn how to simplify that a little bit more. But for right now, that's as good as we need to get. So let's move on here a little bit. Okay, we were talking about the square root portion right there. That portion of the square root is called the discriminant. Okay? The discriminant. And that's the square root of b squared minus 4ac. That's the discriminant. Okay? And you can use that to determine how many answers, how many roots, how many zeros each problem is going to have. Okay? So if I take a look at this, an example here. If I have 2x squared plus x plus 3. Okay? If I go ahead and do the discriminant, the square root, if I do b squared, 1 squared minus 4 times a times c, I end up with the square root of 1 minus 24, which is the square root of negative 23. And if you think back, the square root of negative 23 you cannot do, because we can't take the square root of a negative number. Okay? What happens is, if I can't take the square root of a negative number, that means there are 0 roots, or zeros, or solutions, whatever term you want to use. Okay? So the graph of this equation would end up looking something like this. If you remember from section 1, the graph never touched the x-axis. Okay? If it never touches the x-axis, there's no solutions. So if I look at an example for 0 for the discriminant, I could have x squared plus 6x plus 9. So when I take the square root of this, I'll have 6 squared minus 4 times a times c, which gives me 36 minus 36, which is 0. Okay? If I get 0, that means I have one solution, and that was when my graph looks like this. It just touches the x-axis at one point. And the last one we had, if I do the example x squared minus 5x plus 2 equals 0, I can take the square root of negative 5 squared minus 4 times 1 times 2. Negative 5 squared is 25 minus 8 gives me 16, which I know is positive or negative 4. Okay? So that tells me that there's going to be two solutions, and that's a graph like this, where it's crossing at two different spots. Okay? So that's what we're going to do with the discriminant. Okay? And you're not actually finding the solutions here in the discriminant, you're just finding out how many solutions there should be. If it's negative, there's no solutions. If the discriminant is 0, it's one solution. If it's positive, it's two solutions. Okay? So here's a few examples we'll go through real quick. Use the discriminant to determine the number of real roots for each. So I take the square root of 10 squared minus 4 times a times c. Okay. That equals, if I have to do this really quick, I'm running out of time, I apologize, 100 minus 88, which equals radical 12, which means there's two roots because it's positive. Okay? So if I go ahead and I go through it, I don't have time to show you everything here for example B and C. But example B, you should get one root. I'll have the negative square root of 20 squared minus 4 times 25. And so I get radical 400 minus 400, which is square root of 0. So there's one root. Okay? And you can guess that this one should be 0 roots. Again, I don't have time to show you the whole thing. But go ahead and try that, please, on your own. And if you don't get 0 roots, meaning if you don't get a negative underneath the radical, come see me or try it again and see if you can figure out what you did there. Okay? Now, chapter review here real quick. A little recap of how to solve quadratic equations. The first method we have is called graphing. That's what we did in section 1 of section 1 there for graphing. It can always be used, but it's not always exact. It's tough to tell where it crosses the x-axis. So only really you want to use it when you're specifically asked to. Factoring was back in chapter 8. Okay? It can't always be used. Remember, there was times where we couldn't factor stuff, and we said it was prime. Okay? So you really only want to do that when you can look and really determine quick what the factors were. Completing the square was section 3. Okay? Section 3. It can always be used, and it's useful when b, the term in front of x, is an even number. As some of you saw, when it's an odd number, you end up getting these weird decimals, and it's not as fun to work with. So you really don't want to do that unless b is an even number. The quadratic formula is what we just did here in section 4. Again, you can always use it. It will always be 100% accurate, but it's not always the quickest way. Okay? So, I hope we got here with section 9. Remember, you can always go back and watch these and pause them as much as you need to. Please, please do that, because the only way you can understand this tough material is by spending time with it. When you just breeze right through it and don't pay attention, it's not going to make any sense. You have to spend time thinking about the material and focusing on it in order for it to make sense. Okay? So that's it for for chapter 9. That's it for section 4. Good luck on your tests, and we'll be seeing you. Bye.